All right, today's lesson that you're going to do, you'll also do some practice in the book. So put the books away and watch. Put the drawing away and watch.
I'm writing what you read on the board.
Okay. It's going to be talking about least common multiple and least common denominator. Least common multiple and least common denominator. For those of you that watched, I did a video on this yesterday in my third class, so you could see what it was. I may have done a short lesson in this class.
Yes.
Did I? Okay. So I've done a couple lessons on it. Least common multiple and least common denominator. I'll show you this, and I'll add in least common denominator today. But some of the work you're going to have to do today is going to tell you to find the least common multiple. So what I'm going to do is I'm going to do a couple problems. And remember, when you think multiple, the word multiple is in multiplication. So it's just like using a multiplication chart. So think of it that way. We're going to find the least common multiple of 2, 8, and 12. So the question we have right now is to find the least common multiple of 2, 8, and 12.
It's 24.
I want you to be quiet. Unless I ask you a particular question. Now, the more you practice, obviously, the better you'll get. The more you practice, the better you're going to get. Now, obviously, you have a multiplication chart. When you have to find least common multiple or least common denominator, my advice is to you is use your multiplication chart. It'll save you much time. It'll save you much time. But before we start, we'll ask ourselves a few questions. We look at the largest number. The greatest number we have on there is what, class? 12. Okay? Does 2 go into 12 evenly? Yes. Does 8 go into 12 evenly? No. Okay? So, if I just start with my largest one, and then list it through and see if my smaller ones go into that number, might save me some time. Otherwise, now as Fred's already said what it is, okay, again, I'm going to start with my greatest number, which is 12. Okay, we know 12 times 1 is 12. What's 12 times 2?
24.
Now, all we have to do, I know 24 is a multiple of 12. Is 24 a multiple of 8? Yes. Is 24 a multiple of 2? Yes. I'm done. I don't have to list it out. If I just take my largest number, and every time I do another multiple of my largest number, ask myself, is that number a multiple of this? Is that number a multiple of this? Okay? So then my least common multiple equals 24. Okay? Now, how is that used with fractions? Thank you for asking that, Hunter. Let me show you how it's used with fractions. As you learned last year, you learned how to add fractions with like denominators. With the same denominator. You cannot, and I mean cannot, add fractions unless they have the same denominator. So let's take these fractions. We're going to add 1/2 plus 3/8 plus, let's say, 7/12. So let's say this is our problem. And as I just said, you cannot add these fractions together because they do not have the same denominator. So what we just did a moment ago is we found a common denominator for 2, 8, and 12. Remember, the number on the bottom is our denominator. That's how many total pieces there are. How many total pieces there are. So if I had a pan of brownies and I cut it into 2 pieces and ate 1, that's my fraction 1/2. If I had a brownie and I cut it into 8 pieces and I ate 3, that's our value of 3/8. If I had a round of brownies and I cut it into 12 pieces and I ate 7. So the top number is how many pieces you had. The bottom number is how many pieces there are. Numerator on top, denominator on bottom. So now, as Hunter just told me while he's putting his hands on his desk so he's not playing in his desk.
I'm eating.
Well, put your food on your desk, otherwise I think you're playing. Okay? I cannot add these the way they are written. I figured out my least common multiple, which is the same thing as finding my least common denominator. So I'm going to take these fractions and I'm going to give them
I'm 24.
a denominator of 24. That's second warning before I send you out. I'm going to give them a denominator of 24. However, I cannot change the value of the fraction. I can't say, hey, I don't want to add 3 plus 8. Let's make it 4 plus 8. That changes the answer. I cannot change the value of the fraction. So I'm going to multiply each of these fractions by a fraction that equals 1. By a fraction that equals, that's a horrible one. Now, as you know, if you multiply something by 1, you're not changing the value. If I have $1 and I change it for 10 dimes, I'm not changing the value. Oh, let's call on Olivia. Can you give me an example of a fraction that equals 1? Think about our brownie. If it had 2 pieces and I ate 1 whole pan of brownies, how many are there going to be? Okay? So there's going to be, that's going to equal 1. I'm going to equal 1 whole pan of brownies. The microphone is muted. Is it muted? How do I unmuted it? We're up higher. Is it better? Oh, it's muted in here. All right. So now I want to multiply this by a fraction that equals 1. As Jocelyn said, or not Jocelyn, as Olivia said, any fraction that has the same numerator as denominator equals 1. If I cut my brownie pan into 2 pieces and I ate both of those pieces, that fraction is 2 over 2 because I ate 2 out of the 2 pieces and that equals 1. So then I have to ask myself, self, what do I multiply times 2 to equal 24? Evan, 12. So I have to multiply this by 12 over 12 because 12 over 12 equals 1. I am not changing the value of 1/2. I am not changing the value of 1/2. What do I have to multiply here? So I have a denominator of 24, class.
3.
Because 8 times 3 equals 24. So I multiply this by 3 over 3. All right, class, I have 7 12ths. What do I multiply that by to give me a denominator of 24, class? 2 over 2. Okay, so we're aware, as Olivia told me, if you have the same numerator as denominator, your fraction equals 1. So I have multiplied 1/2 by 1. 12 over 12 equals 1. If I multiply straight across, 2 times 12 is 24. 1 times 12 is 12. Those are the same value. If I have my brownies and I cut it into 2 pieces, 2 equal pieces, and I ate 1 of them, I've eaten half the brownies. If I have my brownies and I cut them into 24 pieces, and I ate 12 of them, I ate half of the pan. Okay? And you kind of need to start thinking about halves. You should be able to understand halves. If the numerator is half of the denominator, then that fraction equals a half. Halves are very easy. You ought to be able to look in your brain and figure out what halves are. Now, 8 times 3 is 24. What's 3 times 3? 9. Okay, so 3/8 is equivalent to 9 over 24. 3/8 is equivalent to 9 over 24. 12 times 2 is 24. What's 7 times 2? 14. Okay, you've learned two things just now. Real quick, you've learned two things. One, you've learned, actually maybe even more than two things. You've learned how to find common denominators. You've been reminded that fractions that have the same numerator as denominator equal 1. You've been reminded that if you multiply a number by 1, it doesn't change the value. And you learned or reminded that you can't add fractions unless they have common denominator. But you know what else you just learned without knowing you learned it? Alexander?
At least common multiple and least a common denominator go together.
Good. But you also learned how to multiply fractions. You just learned how to multiply fractions. You multiply fractions straight across. Woo! So, let's see, this video has been on for 11 minutes, and you learned how to multiply fractions as well as all those other things. Now, we could add these up as they are. I'm not going to do that right now, but we could add these up as they are.
Can I tell you the answer?
No, you can't tell me the answer. Right, is there anybody that doesn't understand what I just did? Okay, I'm going to do one more example, and then we'll stop, and you guys will have some time with a group to practice. So let's look at one more example. Let's take 6 and 9. So let's take 4 6 plus 2 ninths. We need to find the common denominator. Yes? No, there's no butterfly method ever in my room. So let's take my two denominators, and butterfly method isn't for this anyway. So let's look at my multiples. Is 9 a multiple of 6? No. So what's 9 times 2? 18. Is 18 a multiple of 6? Yes. So I could change these so they're both over 18. And what do I multiply 4 6 by 2? So I have a denominator of 18. Anyone? Anyone? Speak up.
3.
3. So I multiply by 3/3. Now, how did I get 3/3? Well, if I multiply straight across, 6 times 3 is 18. So, and I have to have it equal 18. So 4 times 3 equals 12. Oh, that says 14. 12. Okay? So, again, I got to multiply by a fraction that equals 1. Okay, so what do I multiply 2 ninths by? 2 over 2. Because 9 times 2 is 18. 2 times 2 is 4. So as a reminder also, when you add fractions, you only add the numerators. The denominators stay the same. The denominators stay the same. And I'm going to tell you, when I see errors in adding and subtracting fractions, a lot of time the errors come because you're also trying to add the denominator. So please, and the rock means please, do not add the denominators. Do not add the denominators. Adding and subtracting fractions, you find a common denominator. Once you have your common denominator, you add your numerators, and then the denominator stays the same. And of course, you have to simplify. Let's look at simplifying real quick, because you did this last year. Now the same rule applies. The same rule applies. If I divide a number by 1, I'm not changing the value. 14 divided by 1 is 14. 7 divided by 1 is 36 divided by 1 is
36.
Okay? So I'm going to divide 16/18 by a fraction that equals 1. I don't have all these memorized. Well, what we've already done is greatest common factor. So we're going to find the greatest common factor. We've already done that for 16 and 18. So I'll list my factor pairs. 1 times 16, 2 times 8, 4 times 4, 1 times 18, 2 times 9, 3 times 6. Any others? Any others? Anyone? Anyone? Bueller? What they have in common are 1s, 2. Do they have 4 in common?
No.
8? No. 16? So what is the greatest common factor for 16 and 18? 2. 2. So if I divide this by 2 over 2, 16 divided by 2 is 8. 18 divided by 2 is 9. What kind of fraction is 8/9? Improper or proper? Proper. Proper fraction. Okay. You have access to this video throughout your life. So when you get to this, when you're doing assignments, please rewatch the video if you can't remember. We're going to do some work out of the book. It's also going to have examples. We'll eventually put some of that in the journal, so you'll have access to that as well. Peace out. Love y'all. Be blessed.